a lot quicker that life is in factor form. What does factor form give you, Austin? Roots, okay? So I'm going to write this on the board, May the 7th or May the 3rd, 2017. Warm up. Graph. F of x equals x minus 1 squared. 2x minus 3 cubed, and x plus 2 squared. Okay, so let's talk about it. All we need for advanced functions for this, we need three things for advanced function, at least when I taught it. You need the roots, which somebody said, what else do I need to graph this? I need two more things. Go ahead. Yeah, the order. The order of the root's good. The roots with the order is definitely for this one, 100%. Okay, but two other things. That's good, though. Two other things I need, though. Go ahead, Derek. Yeah, and behavior, definitely. Okay, and we'll remind you guys how to do end behavior. What's the last thing possibly that you need? Go ahead.
If it's like negative or positive.
Yeah, okay, that helps with end behavior. Yeah, intercept, that's the roots. I'm going to write down y-intercept here, just because I like to see it. I'm not sure if your teacher made you do that or not, but I'm going to make you. All right? Roots. Now, what are my roots, and are they single, double, or triple, and what does that mean? I'm going to pass for 1 sec. Okay, Derek, you're out 2, and Austin, you're out 2, and Michael Hatcher, you're out 2. Okay? What are my roots here, please, and what does a double or a triple or a quadruple root mean? Go ahead, Nathan.
You got one as a double root, which means it balances off where it intersects.
Now, it's a way to think if it's a double root. All it means is that it looks like a parabola. That's what it looks like when it hits the intercepts, okay? That's what it looks like. Can I get another root, please? Go ahead. Okay? So this one, 3 over 2 is a triple, or a 3, so. And it's what did you call it? Okay. I'm going to call it that. Is that what you mean? Yeah. Okay. What does that graph look like? Sort of. It's supposed to look like x cubed. That's what it's supposed to look like. You can call it a kick, whatever you want to, but it looks like x cubed.
I thought it just passes through.
No, it's goes through. Because it's going to look a little bit different than an order 1. An order 1 would just go straight through. Order 3 sort of does a little bit of this, and we'll show you why that is in calculus this year. I got a third person in my third root, please. Go ahead, Victoria.
X equals -2, and it's a double root.
Yeah. Okay, now we don't know. Hello. We don't know if it's going to. I know. It's an unfortunate that the heat's coming right over there. So you know it's the worst. Yeah, I can leave that open. I think. Yeah, leave it open. Okay, end behavior. What's the end behavior that's going to be? Is it an even function or an odd function? How do you know? Michael, go ahead. Okay, out of the orders. So I have a 2 and a 3 and a 2, which is 7. 7 is going to be what? Even or odd? Odd, thank you. Okay. Is it going to be positive or negative?
Positive.
How'd you get positive? Just to reveal that out.
Because like at the beginning of the function it doesn't signify that it's negative, so
right.
I'm just assuming it's positive.
There's no negative, so it'll be positive. What does the end behavior look like for odd positive? What does the graph look like? The basic graph. Sure about that? No, odd positive. Odd would be like, I see somebody doing like the function dance here, okay? This should look like y equals x, what it should look like, right? So the way you write that is, did your teacher say Q3 to Q1? Is that what they called it? Or do they say as x goes to negative infinity, y goes to negative infinity? They do. Which one do they do? Okay. You can say it looks like y equals x. You can say it goes from Q3 to Q1. You can say as x goes to negative infinity, y goes to negative infinity. Any one of those is okay. And my y-intercept, I'm just putting that in there so I can see how big this graph is, which is huge. It's going to be 8. I think it's going to be bigger than that. Negative 108? Okay. Okay. And we'll talk about in this course how to find like the vertexes or like the mini vertexes all the way through. To see how things go. Is this coming back from most people from last semester, hopefully? A little bit?
Are we gonna need to know how to, like, remember to do, like, the x approaches, negative infinity, y approaches?
We're gonna talk about the limits, so that's like a limit. That's like a limit, okay, so yes, we will be doing those guaranteed. Okay, let's graph this. Oh, come on, there we go. All right. So how do I graph this? Well, I get my graph paper first of all. Hopefully it's here. Whoa, no. Okay, so I got my graph paper, I draw my lines, 0, negative 108. This is not going to be a perfect graph. This is going to be a sketch. Now, please be careful, because on your test, I'm going to give you this much graph paper. Okay, Michael? That's going to be how much graph paper I give you on your test. Please make sure you don't have a point like this, and a point like this, and a point like this. What should you do if you have points that are outside of your graph paper? Go ahead. Change your scale smaller. And I laugh about this, right? But every year I do a graph, and somebody does this for their graph, okay? So please don't do that, okay? If your points are outside of sort of how the graph paper is, change your scale. Okay, not just a warning. You will be penalized if that happens. Now in this case, it doesn't really matter where scale is, because the only point I have is negative 108.
Wait, why 108 again?
Because we plug x equals 0, so
okay.
That's 1, that's 27, that's 4, 27 times 4 is
Right.
Negative 27 times 4. So 108. Okay, there's the best thing that I can draw. For those who haven't been in my class before, I do want to see arrows on all 4 corners. I do want to see y and x. I do want to see numbers, okay, because I can't read your mind. There's negative 108 somewhere down there, okay? Now, why did I use 2 squares in this case for every x point? Why did it make sense to me? We're not going to teach you my grade 9s again here. Why did I not just go 1, 2, 3, 4 small like this? Why did I go like 1, 2, 3, 4? I need 2 squares. Any ideas? Right, spacing is 1, yes. Well, look at my points. Yeah, my points is 3 over 2, right? So I can very, very easily do a 3 over 2 like this. Okay, very easily. Then I have 1. Then I have negative 2. Okay. End behavior we say is Q3 to Q1, so it's going to look something like this. We're going to have a triple root. So let me draw this. A triple root we said is going to look sort of squiggly. So it's going to look like a kicker is the word they use. That's sort of like that. Okay, so it's going to look sort of not go straight through. It's going to be curved as it goes through. Then a double root up like this. Going down to negative 108, drop down here someplace, and a double root there. Okay. We'll talk in this class how you get all the information and the in-between stuff, because that's a rough looking graph if you don't mind me saying so. Okay, so we're going to talk in this course how to make it more pretty, where the turning points are, how things actually to make it look good. For that, Michael, go ahead.
I thought that the 3, 1, 3, over 2 is balancing.
It is. So this is an order 2, and that's an order 2, right? And then this one's going through. This is 3 over 2 right there, right? So that's, yeah, 1.5 is 3 over 2, right?
Yeah, I get it.
This has come back for most people, so we're probably don't want that many squares and cubes in one question, but there are now. All right, I'm going to hit pause the video, and then I'm going to just start the lesson here today. Hold the video, my lesson.